Hello everyone, welcome back to this homeschooling 3D modeling videos, lesson number 9. In the previous lesson, we started modeling this Byzantine architecture. We modeled the bottom part, and today I'm going to focus on modeling the pillars. I want to show you that I was able to get a hold of the original object, and this is much nicer, really beautiful how it looks. And I had to do that because I'm going to use that to reconstruct, and we have to have a very clean shape. You can also see over here in the faces that we are close to 500,000, where last time we dealt with something that was just about 40,000+ faces, and 500,000 is quite big. Many software wouldn't be able to manage that well. And we are going to use now the first tool, actually a tool that is remarkable, that I'm surprised it can handle 500,000 faces, which is quite remarkable. So the goal would be to reconstruct that using this as a reference, but different than we used before. If you remember in lesson number 7, we used an image as a reference that we traced and we drew on top of the image. In lesson number 8, I used a 3D object, this particular object, as a reference, and we drew on top of this one of these staircases or whatever this is, steps or bricks, whatever this is. And then in this video, we're going to use this physical object. I mean, technically it's not physical, it's a digital object, but you get the point. We're going to use this object by itself to reconstruct itself. Why do we need to do that? Well, first answer is because I want to show you some cool tips and tricks. The second answer, and teach you some new tools, obviously. The second answer is because if we do it this way, we master that way, we can actually customize this brilliantly to your own needs. While still using the original architecture. I don't need to redraw things like that. So are you excited? Well, I am, so let's get started. We're going to use the first tool is going to be cube selection. I think I've shown this before. I don't remember exactly now in which video. And this has a dual purpose. It's a purpose of something where you can select something, just make a selection, or you can select something with exact selection, which will cut out. If you have exact selection on, whatever is selected will be exactly cut. So if a face is partially in, partially out, it will slice it. It's kind of like a knife, and it's a cubic knife. As you position it, it's actually, yeah, from all sides, it will cut. This is a knife, it will select everything. With exact selection off, it's just a selection. It will simply select things that are completely inside. Similar logic to if you remember what we have discussed about the marquee selection, where you can drag it from left to right or right to left, and one side it selects everything that is completely in its path, and one side selects everything that is just even partially in its path. So for me, I want to enable to get one pillar isolated. I don't want to cut other pieces and select pieces. I actually want them to select only things. So if I manage to position it correctly around the pillar I want to get, it will be much easier for me to position them with exact selection off. There's also transparency. Sometimes you want to see through what's going on when you're cutting. If you're cutting like a surgeon, you need to see what's happening, but in this case I don't care about it, especially I'm not going to cut. So the color first of all is highlighted. That shows you that everything now is selected because everything is done, and I am going to start cutting. But I need to show you one trick first. So let's exit from here for a second. I need to cut this on top, reach this part. So how do I know the height of this? We know the measurement tool we've shown before, but it's not that easy to get inside here and measure this. So sometimes you have to get clever. So let's go to my 3D sketch, and I'm going to show you a tool we used before. I'm wondering if you thought about this. What am I going to use? Think for a second. What am I going to do now? If you thought what I'm going to do now, then you're brilliant. So let's see. Let's continue. We tried in the previous video, we used this magnet tool over here to offset. I'm going to use that, not because I'm trying to draw, just because I want to figure out the position. You remember I said that could be used for measurements? This is no better place to use that. 4.5. So I know the height is 4.5. So I already measured that before. The top where this is 150. So this is 4.5. The top would be 154.5. So at least I save a little bit time. I could measure the other sides as well, but for now at least I know the bottom would be 4.5, and this gets me, you see, we'll still select this because this has it going deep in. So I will have to manage that, but at least I get it off where I need it over here. And the top this is 150, so this would be 54.5. And this got me down over here. So this saved me a lot of time guessing. Now I know there is a 30 radius between them, but I can move it on one side. Let's say we have I'm here the front, back, left, right. So I can move the right side to, let's say, 150. I think that will do it. That should be about right. So yes, so this is kind of, actually it's not exactly, it's 129 probably. 151 I guess, 151, probably something like that. I can clean it up later, and then I will start doing the same thing on this side, which is my front side. So I'll put it on the front by, let's see, 151 or maybe 150, I'm not sure exactly. Actually it looks like it's not kind of exactly symmetrical. I need to make it a little bit less. So let's just try to eyeball it because I don't know the exact measurements. Oops, I clicked here. I could kind of go all these measurements, but yeah, for now let's start eyeballing because I'm going to clean it up anyways afterwards, after what I get. So you see I got it over here right to this pillar. I'm going to move it over here to make sure I get only this. And again, if I would have exact selection on, it will take me much more time to do that because it will select everything in its path. But now if faces are just partially intersecting, it's not going to select them, and so I save a little bit time. So now I'm going to move this here. Let's see, it doesn't even select these faces because it's not completely intersected. But here I'm actually left off a little bit too short on my front side. So my front is 133. I guess I gotta make it 134. Oh, actually 134 means it cuts it more, so I'm sorry. I gotta make it actually, no, I did. Okay, yeah, that's good. Okay, so it looks like I have it right over here. So at this point, if there's no exact selection on, this is just a selection basically, kind of marquee selection, but a cool way of selecting. So I'm just gonna finalize this. And now I can do a few things. I can just copy this, or I can go, in this case, I'm gonna show you a split. I can actually split this off from this tool. I'm gonna go split. And I think we used before split. I know we used it where split a face off. For now, just splitting this off takes probably a little bit more time than actually copying. But yeah, that's what we did it now. And I'm going to isolate this because that will hide everything else. So you see how clean cut we got. We got a cut over here, which is actually brilliant. This part is selected. We have the top. I tried this before and I got it without the top actually. And then I was showing fill polygons, how to fill it. But now actually you see we got this. Let's see, you still have here to fill. Let's see where we're gonna fill it. Let's say I go over here, fill polygons. That can fill anything that needs to be filled, and actually fill this top as well. So okay, so in case you get some cuts. So this is quite clean. I want to show you something else before I start reconstructing this. I want to show you something else that I've not shown probably before, that how can I see what's going inside here. So first of all, I think I've said before in the camera video in the beginning that you can zoom into a place where it is. If I start hovering my mouse over here and I start zooming, it will zoom into this point. If I move over here, let's say I start zooming into this point. But if you want to see inside something, you just zoom into a point where this comes behind the camera lens kind of, and then you are inside to it. Then you can start seeing inside what's happening, or you can see it even the other way around. So I want to see what's happening here actually. So I'm going to zoom into this side, kind of go into it and see, and I can start seeing the construction. Let's see, once I'm inside, am I inside? I can't see much this way. So this way is not a good direction to see. It's closed over here. And over here, I can start seeing a nice, more wider object, like in a house. You can zoom in and see what's going on. Over here, it's quite difficult to see what's happening. It's actually, I can see, I'm surprised before I did manage to get a better camera angle, and I did see inside what's happening. But still, because it's a very thin object and radius-wise, it's very difficult to zoom in without going into the other parts and see it. So if you want to see an object like this inside, how can you see it? Well, let me show you a trick. I need to select the object obviously first. I select the object, and then we have in utility something called flip normals. And before I flip normals, I'm going to turn on here a thing that is called backface calling. And if you turn this on and off, you see now this, I can make it no calling, or I can make it backface calling on, and now you don't see any difference. Nothing is here. But if I'm going to flip normals, you'll see the magic. Now you see what's happening inside. Look what's happening inside. This has been constructed actually brilliantly, which has a part on top that it's kind of like, looks like one side connected, and it looks like the other side was made with a screw inside, kind of like to screw to screw around. So if you're going to 3D print this, that's probably the idea. You can print them separately because otherwise you need tremendous amount of support structure between these things, and it's just a waste of time and money and it'll make it more difficult. But if you print them separately the top of it, separately the bottom, and then separately the pillars, and screw them on, this will make it look really nice. So it looks like there's been some screw setting over here, and I can't unfortunately see, and over here looks like it was kind of like just a place to put it in. I'm not sure exactly, but why is this working? What is backface cooling doing? If I can turn off my backface cooling, this is, you see everything. So let me explain you what this is doing, and this is what the normals are doing, because we're actually going to use this later in the lesson as well, and that's something very important. So every face has a direction. You can think about it like tiles. If you put on tiles in your house, and you can think about, you have the tiles that one side has like the cement where you're going to put it down, and the other side has the shiny side. It's a similar concept when it comes to 3D modeling. If you have a face, there is the side of the face that is facing outwards. That's called the normal is the direction where it's going. So that means it faces outwards, so the normal would be going kind of pointing away from the face, perpendicular to the face, and that's the correct side, that's the shiny side of the face, so to speak. The other side is kind of the inner side, it's called a back face. That's called a back face. In many applications you have an idea that you can only see the front faces, not see the back faces. So that's basically what this is doing, backface calling. The idea is that when you model for games, especially if you're going to deal with objects like 500,000 polygons, it becomes very expensive for the computer to render that. And if you're going to have a lot of props and games and so on, you really don't want to render so many faces. So what's happening is, if you have something that's called a shader for backface calling, that means it hides everything that it's not facing outwards because you cannot see them. And similarly, there's a lot of, that's from rendering perspective. Similarly, there's a lot of algorithms, a lot of tools that uses algorithms that actually operates based on the direction of the faces, based on the normals. And if something is inverted, flipped, the tool may not work as expected. So CellCAD has therefore a tool for flip normals that you can flip your normals back and forth, and you can fix flip normals. But I use it as a trick now that if I want to see what's happening inside, I simply invert all of the normals, I flip everything, so it tells the computer that the shiny side is facing inwards. So show me only this, and the things that is the opposite side, just doesn't show it to me, so I can see what's happening inside, which is quite a clever trick. Now let's see, I'm going to flip back all of the normals, and now you see it's gone. You know, everything is working fine as expected, but I don't need this on, I'm going to turn it off. Okay, that's enough preparation here. Now it's time to go to the action. So again, we're going to use a tool that we used before. I'm actually going to rotate this first because I'm going to use this soon in the other direction. Actually, I can do it in this direction, but it's just I guess easier to keep me using this direction. So I'm going to use my Z, it's just too high a little bit. I'm going to rotate it at a 90-degree angle. And I need to get a profile out of this. We discussed in previous videos extensively about profiles. I need to have just this profile, but how do I get this profile? It's quite complex to get the profile. You may think, why don't I use loop selection? And the answer is because if you look at the wireframe mode, you see this as a very complex structure that I cannot loop select this. Loop select will work only in quads. And this has a lot of triangles, a lot of stuff done. And this is not something that I can work with loop selection. So I need to find another creative way to get out a loop from here, to get out like the basic profile. So I'm going to use a trick that I've used before, but now putting it together as the puzzle, the pieces, and you'll learn how to use it. I'm going to go to, first of all, flatten. I'm going to flatten this completely down to one side. So I can make it down, flatten, just drag it down aggressively, and it's flat. Now, you know probably what's going to happen now. The problem that I've shown before, there's something idea about duplicates. Maybe I've not shown it before. If you remember actually in one of the videos where I used split and merge, what I said I used it before, because I had the problem with loop selection. Actually, that problem I figured out later was a problem with duplicate vertices as well. Because a lot of times when you do something, operations, in that case was some sort of beveling or extrusion, that I made it overlap one face with another. But in this case, for sure, I aggressively move it down. I have a lot of faces overlapping now. It's kind of like a completely destroyed object. So this will make me a lot of issues. So I'm going to go to remove duplicates. And also it will reduce the amount of sizes. Look how much we reduced. It's amazing what it reduced. And now I actually need only half of it. So I can still get the entire revolution, entire perfect thing while it's flattened, while I can get only half of it. Just watch. But the first thing, how do I get half of it? I know the radius of this, I calculated that, measured that, is 30. But that means I need to move it in one direction to flatten that again. I need to move it, slice it in half by 15, move it by 15. But the problem here is that if I use the text boxes, those are always symmetrical, meaning we'll move half of the 15 from one side, half from the other side, and I need to keep one side intact. So how do I do that? I can start moving the gizmos, manually drag them, and start seeing what's happening, but it's quite difficult to get a number. You see, I'm looking at how it goes. It's quite difficult to get a number 15 straight. Actually, I did get it now, 15, but it's not always that easy. So actually, it looks like it's 20, and I need to go to 10. I actually thought it's 30. Maybe I'm wrong. Maybe I need to go to 10 in that case. But nevertheless, it's still quite complicated. It's difficult sometimes to get it exact with moving the gizmos. So there is a tool here that actually has been added recently, which is minimum step size. And minimum step size will mean that every step when I'm moving it will move in a certain size. I actually want to test if I can enter 0. Looks like I can enter 0. But I'm not sure how it helps you start moving, but for here, definitely you can add fractions. But over here, usually you want to use it with steps. So I'm going to make a minimum step size of 5. And if I do it 5, you can see what's going to happen. I move it at step 5 and then step 10. And if I want to make 15, I move again 15. But it looks like it's 20, so 10 would be the correct way to go. And this just makes it easier for me to get it in this way. But because I collapsed now other vertices, I need to remove the duplicates again. And we again removed quite a lot. So now we have this, how we convert that to the magic. I go to the freehand drawing, and again, it's a tool I used before. I'm actually going to hide this away so it doesn't stay in my way. And I'm simply going to drag and drop this. I've shown this trick before, but now you see it in action with something meaningful. And look how this is nicely laying it out. It removes all of the interfaces and it creates both of them. It's kind of like animating it while it does it. Okay, so now I have the profile, but if I'm going to finalize this, if you remember from previous video, it's going to give me a height and just extrude that. I don't want that. So I'm going to go to my height settings, and you remember from previous that the default is 20, but if I make it to 0, I get, and I confirm it, I get a profile. Voila. So we can get rid of everything else. I can actually delete everything else now. Let's go and highlight this, just delete these away because I have it. Why can I delete them? Because I have them in my projects. If you remember, we said before we should save things in projects. It's in my projects. Those is already saved. So I have no problem with that. I'm going to rotate this again back to 90 degree around the Z, minus 90. Okay. So now we have this object. Look how nice this profile looks like. I mean, this would take some time to draw with so much precision. To follow it exactly, but yeah, I'm happy I got it this way. So now I'm going to show a tool that it's called Revolve, and the Revolve tool is going to do the magic. A tool called Revolve, and this tool, I want to show you how this works. You can revolve it without doing anything. Just click Revolve, it will revolve it. This will revolve it around something. I'll show you in a minute how the revolve around is working. But you get the idea. You see this profile, unless you hide them away, hide all objects, then you wouldn't see it. But if you uncheck hide all objects, you see how this is working. It's kind of like, if you remember in the previous video, we showed the pivot, how you can pivot something around, and it makes copies while it rotates. Well, this is kind of extrudes along while it rotates around these things. And it depends where you rotate around, what's doing the inside. But this is rotating it by default in a way that it creates it hollow inside. You can play around with that, change it, and you can use these gizmos and start moving it the entire thing at once, and you get a different shape. You can move in the other direction, get a different shape, you know, try doing things like that, quite interesting things you can play. Or you can move it in, let's say, you can move it just one direction and get it like skewed in other directions and so on. So you can do a lot of interesting stuff you can do with that. Look how you can get some very interesting shapes that way. But this is not what I'm trying to do now. And you have something flip normals, because in many cases, if you give it, say, look how beautiful this is. This actually creates a beautiful object now. Look at this. This is very nice. Really, really nice. So you can do it as a lot of stuff. And in some cases, you want to flip normals if you get in this color, and many applications actually by default flip normals will look a different color. By CellKit, it's very difficult to see what it's flip normals because it has the same color. But within this tool, they actually give it a different color so you can see when it's flipped. So if you see something like this, you click flip normals. If you don't see it, obviously this, and this kind of helps you to flip everything. Otherwise, you need to go to the tool later and flip normals. So because this tool has a tendency of flipping a lot of times, because depending on which direction you go, because you can tell it a different direction and will flip, so they give it this. But again, this is the basic idea how you do it. You can open this up and you see you get just half of it, and the same similar idea we did before with angles and segments. But now the option is also to revolve around an edge. And this is what we're going to use, because this is the way it's used in most CAD applications actually, just this option. They don't have this automatic options, they don't have the gizmo to skew it, just the option to revolve around an edge. And in this case, let me show you. If I revolve it around this edge, I'm going to get the, you see it's flipped normals first of all. It's flipped the other way. I have to flip it, the normals. But if I'm going to open it, you're actually going to see how the entire nice shape is inside. Not the outside, this is inside. Let's see if you can see it over here. We got this nice angles, nice shape inside. And I have fill over here. That's why you can see it clearly. Okay, let's unflip the normals. Because see, the inside is a nice shape, inside is not flip. If you look at it here where you get all of these shapes and it's not giving you exactly what you expect. So what if I choose this edge, and this is what you normally would want. Let me close it. And now I want to flip normals again. Depends where you rotate. It has a lot to do with the scene as well, I think, the location where it rotates. That's why flip normals is kind of like a given over here, the way you have to do it. Play with it. But in this case, look what we got. We got this entire shape. Very well done. I can give it a lot more accuracy, make it very smooth. 200, this will be really smooth. I don't think we need that smoothness, but why not? This looks beautiful. So the basic shape here is done. But I still don't have yet the kind of creases that we had before inside here, and I deleted it actually, I shouldn't have. So let me just finalize this. So let's go and I don't think that I need that smoothness, just we just add too much geometry for no reason. So 100 will be perfect, or actually even 64 should be perfect. 64, yeah, it looks nice to me. It looks very nice. So let's get it like this and let's finalize it. Okay, so we have this. So now we can get rid of this profile actually. You don't no longer need a profile. And I can save it if I want to use it from before. Let's go save object, because this profile is a nice profile. And that's okay. So now let's create the details that we had over here. I can hide away or delete actually the profiles already saved. And we're going to add the details over here. We need the inside. We'll show you hopefully in the next lesson how we can actually create in one step with details, and that would be a different tool. The loft tool would be able to do that. But in cases like this, it's much easier to make the entire revolution with the Revolve tool. Loft tool will require many profiles to do that, and we'll learn that later. So for now, it's much easier for me to use that tool to revolve it, and then we're going to make something else to add this. And this is actually quite simple. The details over here, I have to look first of all the size of it is. I think the size was 150, 149, but it's actually not perfect. So I'm actually going to move it down. I think it's too high. Let's make it to 100. And if you remember, if I scale, it moves it up from here. So I'm going to position that to, this is actually interesting. Added, you remember I did a 10 and still has a radius, a size of 30. I see, that was a radius of let's see, a radius of 15. I don't remember what I did. Okay, so let's go back now to, let's move this down to the bottom, to the center, everything, and I'm going to add the details. So what I'm going to do is now use, again, tools we used before. I'm going to use a cylinder, and I want to make it a height of 80, so it's not intersecting the entire thing. Segments, horizontal could be the same. Vertical segments, let's make it, I have no details, I don't know, let's make it to what, 32. And let's give it a top radius of only 5 and a height of another radius also of 5, so make it relatively small, and a full arc, and that's it. We're going to finalize it. Now this cylinder is completely hidden over here. We can go to the tool we used before, snap, but actually a line tool is a very powerful tool as well for positioning, and in this cases this will help much better. So in a line tool, you open it, you can align things to the grid. Let me first show you how line tool is doing, and one of them I cannot show you while it's selected. Maybe I can, no I can't, I have to exit that. So align tool will allow me to select anything to it. So let's see if I'm going to move this out of the way, then I can align it to the grid, like the center of the grid and so on. If I have two objects selected, something like this, both of them, and I go to the Align tool, it gives me an added feature, merge object centers. I can merge object centers, but that's already merged actually, because both were created in the center, so it's actually both in the center. Okay, it tells me here the grid size, so, but that's basically it. So it's already merged, that's not what mentions it. I'm trying to align it to this object. So if I have only one object selected, it gives me the option to align to the grid, or it gives me a list of everything. And this is named, I said before, Socket names things, you can rename it, but they name it based on what it is. This is Revolve Mesh 1. So I'm going to choose the Revolve Mesh 1, and it gives the error, like by default, the bottom, it will align it below the grid. That was that message was. You can bottom below the grid, but I actually want to align this to the center of this object, and I want to align it to the front, let's say the front of this object. So you see this object already positions over here, but I need this to go inside to this object a little bit. But before I need to go this inside, I actually need to do something else, or I can do it afterwards also. This to go inside a little bit, so this is the direction of Z, so I can start pushing it in, actually negative, I can start pushing it into a little bit into this object. So I'm putting it into, let's say, something like this, and this will give me this, but I remembered I forgot to do one step because this has an angle top, so I'm not going to be able to finalize it before I do that. So I have to kind of isolate that for a minute, and I have to go to the vertex mode and to select the top vertex over here. Let's see, this one, and the bottom, because if I use a cylinder, I mean a sphere, I would have that detail, but if I use a cylinder, I have to kind of make it myself, the angle that had, that shape. So I'm going to go over here to scale, and in scale the size is 80, I'm going to make this size to 90. So I make the size to 90, now I got this angle look, and now if I'm opening this up as well, you see it's aligned to this. I want to make sure the tip is outside. If you remember, that shape had a tip outside, but now I see I made it too big, the entire object, so it sticks out from both sides too much. So I need to scale it back down a little bit. I'm just eyeballing it. I could have measured all of these, so I'm going to make it back to 80. It wouldn't affect the pitch because I'm scaling the entire thing at once now. So this is still going in. I don't want it to go in completely. I don't want it to go in half because this will look pointy. And if you remember, the shape over there had kind of like a roundness to it. I want to keep it in just a part of the roundness to it. But I see another problem. This is too big. This wouldn't be Revolve because I need to have 16 revolutions. If I'm going to go now to my copy offset tool, and I'm going to scale that using pivot, what we did before, I'm going to use the pivot tool, and I'm going to make 15 copies. You're going to get them intersect each other. This may look nice, but that's not for this use case. So I'm going to undo this, and I'm going to scale it again. 5 was too big. Actually, I did it. Oh, 5 radius. I thought 5 size. Okay, that's good. I pointed that out myself in previous lessons that a 5 radius is 10 size, and that's actually where my mistake is coming from. I thought I can do it 5, but I think actually I don't need even 5. I think 3 would do it enough. Let's see, not 103, 3. Okay, I think 3 would be enough. And again, I should have measured that to get exact things. So now I'll be left with kind of aligning it and eyeballing it. Again, I'm going to align it better to this, and I'm gonna make it into the center. This is my, where I'm looking at the camera, right side. So I'm gonna make it the center right. Oh, right is here. So I want to move in the X direction. Okay, so I want to move it in a little bit. The point should be out, but the basic should be in. That's basically what I want to do. Something like this. This is how it should be done. And then we're going to go to the copy offset pivot. Let's see, we got over here 15 copies. And we're going to pivot that. And the rest, you know, I'm going to select this. And I'm going to merge all of them. And then I'm going to take plus the other object. We're going to go to stitch and scoop. We're going to go to difference. We're going to select these pieces, these guys, and we cut them out, and then we finalize it. And here you go. This is how you reconstruct something like this brilliantly. So, but you can obviously, if you see what I just did, you can use any other shape to reconstruct them. And to be honest, I think the edges over here looks even nicer. It looks really clean cut than the original one. Maybe it's still a little bit too pointy, but you see, you can play around. And you can take others. You can take a cubic shape, you can take any other shape. There's another option that I tested before that I can actually do, where I can loop select every second face, and then use extrusion with inset kind of combination, macros. But in this particular case, this was the simplest way. And here you go. I can go now and add the other parts, like make them assemble, adding a screw, things like that. But I think I'll leave this for next video, not next one afterwards. The next video, I hope I'll model the top of it and show the loft tool, which is also and also follow path. I want to show both of these tools, which are really incredible tools. And maybe I will follow up with another video as far as assembly and slicing it for printing and those type of stuff. But for now, that's done. So I hope you enjoyed it. Let me know in the comments if you want me to do something else. Thank you and have a great day.